today I think it's one of the complex subject, and then the idea, at least I have in my mind, to go through some of the simple concepts of why it is required, and when I say why, I mean service mesh, and how when you are running Kubernetes already, it's already a complex platform, and then you are introducing one more complex platform on top of Kubernetes, which is a service mesh implementation. Today we are going to be focusing on Istio. So the whole idea is when you are into the microservice world, when you have hundreds or thousands of instances of services running on the clusters, on that cluster in production or in different environments, you actually have to think about from the concepts of how these services will talk to each other. How will you handle service to service connectivity, security, and of course monitoring, logging, tracing, right, or observability. So that's the topic for today. And I'm Praveen Salitra, cloud architect and head of technology here at Egen. Been here for almost 8.5 years or so with the company, but then company has been in existence for almost now 20 years. Especially in the last 6 years, we have started working with some of the startups, which went on to become unicorns, especially in Chicago. Our solution arm, which most of our learning comes from, actually was created 6 years ago, and then we, as I said, right there started working with containers in 2015 when Docker was not even a year old probably. But at that time we were using container orchestration from Apache Mesos, or going through with real-time data streaming using Kafka. So a lot of learning from data engineering and the cloud modernization sector at this point. So at this point, we work with not only the startups, but unicorns, but then also some enterprises as well in the last 3 years probably that we have started working closely with them, where we lead in from the architecture perspective, and then if they need any help on implementation as well, we have teams, we have engineers, a lot of them are on the call at this point. So as far as our work is concerned, pretty simple. I would say if you understand modernize, launch, and scale, those are the three larger categories that we operate in. And then from the domain perspective, we started from industrial IoT, so have a lot of experience dealing with real-time sensor or machine data, and then doing predictive maintenance on top of it. And then in the last 3-4 years, we went into healthcare as well, handling different kind of problems there, especially with unstructured and a lot of batch processing. And then in the last couple of years, ventured into retail and some of the fintech kind of sectors as well. The whole idea is whatever we have done in our engineering teams, some of the concepts are transferable from one project to another. And that's where event-driven architecture comes into place, data pipelines using modern frameworks, microservices, serverless. Again, serverless not just from the perspective of running function as a service, but then also thinking, okay, how can we have database in the serverless fashion? How we can have CI/CD in a serverless fashion, right? As much as some of these responsibilities we can offload to the cloud, we prefer that way in most of the scenarios. Automation truly, and then observability as well, especially with respect to the data engineering concepts. When you have streaming data coming in with a good speed, or what they call velocity. And then when you have microservices or a distributed platform or entire jazz around it, in order to see where things went wrong and you want to get alerted very fast, observability plays a very vital role. And that's where a lot of exposure to this kind of cutting edge problem actually required us to venture into a lot of different variety of technical stack as well. So whether using JavaScript stack end-to-end on some of our newer, smaller projects, whether using React or Vue or Angular on the front end, using React Native mostly these days on the mobile apps, and then even becoming as comfortable as using Nest.js and TypeScript on the back end, using TypeORM, and then even thinking to the extent that can we provision infrastructure using TypeScript-based constructs, and that's where AWS CDK comes into picture, right? The cloud development kit. Some exploration is going on there. But of course, working with enterprises, traditional stack, but then most of our work these days is in the cloud and the data stack. Not the data stacks, the company, the data technical stack. And that's where a lot of learning comes from. And the whole idea behind collective group, this particular group, Cloud Collective, is to transfer all those learning into the public or community, and then go and then probably discuss how other folks are doing. Of course, we have been hiring probably ever now. So you can reach out to egen.solution/careers, and then you will definitely find openings in engineering and product always, almost always, and sales, marketing, people, and operations sometimes a year. So that's pretty much about egen, and let's talk about the topic again for today. So today we will be talking about how to take this service discovery and microservices connectivity, security, observability to the next level. As I was discussing initially, before probably the recording started, the it's 2 level up than where folks are right now, mostly in the enterprise world. So maybe things are already monolithic, right? The product is still working on. And then on top of it, you thought about moving to cloud or microservices architecture. Then you decided for Kubernetes as well. This is 1 level up and saying, you know what, you are now comfortable with Kubernetes, but the complexities have increased more on top of it. So how to identify those things and how to put some solutions like service mesh there. So agenda is pretty simple. We will talk about typical journey from monolith to microservices, but again, not from technical perspective, mostly from a business, and then also some of a requirement that as a technical architect or a cloud architect or a CTO or director of engineering, whatever, you will be dealing with some of the reasoning behind moving to microservices. Then definitely we'll discuss some operational challenges that comes with those microservices. Again, remember at egen, we have been helping some of our customers to move to microservices since last 5-6 years. So we not only know what are the benefits, more importantly, we also know what are the downsides, and there's no one size fits all kind of solution there. So what are those challenges? We'll talk about those. And then how a service mesh fits into addressing those challenges. What is Istio? We'll discuss and understand some of the components of Istio. And then what are the features that Istio is supporting? We'll probably very quickly walk through some other service meshes as well, like Linkerd or Console Connect. And then definitely if AWS help us at this point, we will have a good demo with installation of Istio on Kubernetes cluster running on AWS EKS, and then we'll play with few configuration and see how all those features or some of those features are working. And then of course Q&A at the end. So that's the whole idea. So going into just very high level discussion about monolith to microservices, right? I mean, just assume you are a cloud architect or a CTO of a small company. You have a delivery app and a platform, of course, and everything was working fine. At this point, it's monolith and everything is okay because you are small. You are small company, product, maybe the user base, everything is small at this point. Maybe you have less than a couple of teams working through it, right? And they're all doing maybe the app work, the DevOps work, the DBA work, whatever it is. So a pretty small group that you have at this point. And then more and more you are getting popular now, right? Your users have started using your delivery app, and definitely now you need to scale because there's a lot of volume of the users, or the load on the system is increasing. You are thinking about scaling the system, right? Or this particular platform that you created. And your current platform, what are the options if you think about scaling, right? Maybe someone will throw, well, we can try scaling it vertically, right? You can try for sometimes, but then it will start costing you too much, correct? Someone will suggest, well, you can think of scaling horizontally, but if things are not properly done, you will hear your architects talking about forget about it, right? It cannot be probably scaled horizontally because you have some in-memory caching going on, which is not going to be available, but you are not in a situation to use distributed caching, or many other kind of things are not going to work out, right? So that's on the technical side. Maybe your growth is also happening. You got a VC firm to back you. You got a lot of funding. Your CEO is saying you can hire many teams now. You want them to run fast. You want to deploy all of 10-20 teams, work on this, and you want to get results as fast, right? Maybe someone got some idea and you want to implement that as soon as possible, or maybe you want to pivot for a bit, right, to a different use case. Maybe the typical idea there would be, if you have the funding and if you are growing the teams and all that, is to maybe create pods around the teams and give them the responsibility of the new set of services end to end. maybe you help them or probably implement some sort of self-service model of CI/CD and deployment, where these teams can decide what is the technical stack they want to use, what are the set of technologies, databases, and everything they want to use, and they can run ahead with it, right? Without creating any bottlenecks or inter-team dependencies. That's the ideal goal that you would want to have. So cool. It's 2021. One of the popular way to go out from monolith is actually into the microservices world, right? Where you may start carving out some most used or most bottlenecked feature out into its own service, domain wise. And then when you do that, many different things, different kind of things will start appearing, probably for the first time. Problems that were never kind of thought of when you were running monolith, right? So again, microservice is not, as I said, it's not a one-size-fits-all solution, but you will want to study in the context of your organization, and probably will start thinking about it, right? And when you do that, your teams now should be able to use any technical stack that makes sense for them or the problem that they are trying to solve. And then they will have to just define the contract between their service, if they are the producer of that service, and what their customers or consumer services, right, the other ones they are using. In some cases, it may be RESTful APIs. In some cases, it may be WebSockets if you want two-way communication, especially with the UI or the client apps. It can be GraphQL as well, something that we have been exploring, or maybe service-to-service communication, but using async communication pattern, right? Maybe using queues in the middle, or maybe as powerful framework as Kafka. So a lot of these things can be possible because now teams, depending on the requirement, they can create and run with their own stack, their own service. Some maybe your batch processors, right? So that's what you will end up having. You definitely would want to invest in distributed caching now. You probably want to explore variety of data sources or data stores, I should say. Maybe relational data should go into the relational databases, right? Maybe you have some requirements for doing search capabilities. So you may start thinking from Elasticsearch perspective or any NoSQL database for some other sort of requirements. Definitely you will have some way of storing files, or not blog actually, I meant to say blob storage. And then ultimately you would want to go towards containers if that is the case you are thinking about it, right? I mean, functions as a service is one step ahead of that, but most of the enterprise and a lot of other customers are still thinking from containers perspective, and that's okay. You will, if you are on one of these cloud providers of Azure, AWS, or Google, you have those managed services to run Kubernetes cluster on top of it, right? The de facto standard for container orchestration today. Or if you are a little bit more, I would say, ahead of the curve, you may start thinking of, if you are on AWS or Google, you may think of Fargate or Google Cloud Run, right? Container as a service kind of a thing, where you just pay for the resources that you will be using for the containers, but not have to worry about managing Kubernetes cluster on your own. Definitely, as you grow and more and more technical skills come to your company, you will be thinking about Git flow and GitOps and infrastructure as code and a lot of good stuff that will eventually come if you become a large company, or at least if the company is small, but at least your user growth has gone 10 times, 100 times, and things like that. So that's when you will be like, okay, it all makes sense now. You see light at the end of the tunnel now, and you say, let's go ahead, let's break this monolith, right? And that's where you will be able to probably make a lot of decisions early on, but then you will quickly run into some operational challenges as well. And our understanding is you have to think about these challenges while your app teams are breaking the monolith into microservices. Your ops team has to figure out how we will be providing this features, or how will we handle these challenges when application teams are dumping their containers to us for us to deploy, right? And what are these challenges gonna be? So one of the foremost is gonna be service discovery, right? How this passenger service knows the existence about the driver service, right? Or the payment service. maybe it's internal or the billing service. Where is that running? What if you have multiple instances of that service running? Who will do the load balancing, right? Should you put an internal load balancer from the cloud, or you should have your own proxy server running and handling load balancing on your own? So that's going to be another important thing. What if, let's say, in this distributed system now, one of the service goes down? What happens to your entire platform? Should you just put 404 or page not found or 500 on your main customer facing page or app, or should you try to at least run your platform, but maybe some degradation of the service will happen? So how you respond to a failure in this scenario? And then when you have a lot of these things going on, specifically if you have hundreds of services or instances running within your distributed environment, you would want to find out where are the bottlenecks. You want to monitor the performances of your services, right? Maybe you want to implement API, app performance monitoring, or maybe, of course, your teams will be asking for logs or traces, or in short, observability, right? All those numbers, okay, when the request is going from, let's say, this customer user to API gateway, and from there to the passenger to the payment and somewhere else, you probably want to be you probably want to have visibility into what is the time consumption here, right? Or the latency between this two versus somewhere else, and who is blocking it, right? Whether it's a database query, whether it's a network connection between two services, what's going on. And then if you start maturing on your technology side, you will start thinking of, you know what, we are so comfortable with our CI/CD at this point, we want to go ahead to something called canary rollouts, right? Or A/B testing, where let's say you are rolling out a new version of a billing service, and you don't want to just go ahead and deploy that new version right away in production. You may want to probably just route 10% of the traffic to that new version. 90% can stay on the existing older version, and you want to see if there are any failures or if the error rate is coming up, right? Maybe, and then if that happens, you quickly want to shut down and then go back to the older instance. Or if everything is going well, then you slowly you want to move traffic from older version of the billing service to the newer version of the billing service. Maybe you are changing your Stripe to Square or something like that, right? So all that kind of stuff, you maybe now start to think about it. And then what if you want to, let's say, limit who is accessing your services? Maybe internally itself. Maybe Square or Stripe or Twilio or anything else that you are using external integration, they have some limits on rate that as per your plan you have to honor. And if that is the case, maybe you want to put some sort of rate limiting internally so that you don't get out or get over that limit from those external providers. So something like that. And then comes another important aspect, right? Maybe when anyone who is talking to the payment service, any service, I mean, they have to authenticate before reaching out to the payment service, probably because payment service is an important service. You don't want anyone within the cluster to just start making requests to the payment service. So you may want to bring in and start thinking of now service to service authentication, service to service authorization there, access control in short. And then maybe if you are flowing PHI, PCI, PII data in some category, you may want to even think of service to service encryption, even though the network or the data movement is happening within your own private cluster. You may have some requirements to handle those kind of scenarios, right? So a lot of operational challenges that you will start thinking as you grow, as your company grows, as your product grows, and number of teams are serving you or working with you now. So there are a few approaches that I just thought about. Okay, how can we implement some of these things, right? One of the suboptimal or not optimal at all approaches, maybe you actually code all of this logic or some of this logic into each of the microservices separately, right? Maybe you are using a similar technical stack. You can actually probably think of creating reusable components or libraries for all this, and then import into the services that can handle, let's say, retries, that can handle tracing, that can handle rate limiting, that can handle maybe authentication, right? Maybe each service talks to the auth service in order to authenticate when it's getting requests from some other service. So you can think of all these approaches. The problem there is you will end up having a lot of repetition everywhere, right? Definitely, as a good architect, probably you would want to keep your code dry, right? Don't repeat yourself. So if that is the case, but what if you have multiple programming stack? What if passenger service was written in Python Flask while the billing service was written in Node.js, right? Or maybe your driver or trip management was written in, I don't know, Ruby or something else, right? So in that scenario, you probably will end up creating copies or same idea implementing in different programming stack as well. So not a good solution, or not a straightforward optimal solution, I would say. What if you can extract all of this in all of these operational requirements that you have outside the code, outside the purview of your application's team? What if they don't have to worry about it, but you can figure out some framework, some sort of tooling on top of your orchestrator that can handle these requirements by using a pretty simple, I would say, configurable manner, where you can give some things to your application teams to configure for their service, and it does a lot of this work automatically by injecting a lot of new things. And that's where actually service mesh comes into picture. The whole idea is, if you are running on Kubernetes, that's a base example that I will take. If you are running it there, can you achieve all of this, or most of them? We will be able to achieve all of them actually, using something where your application teams don't have to write that logic in as part of their code, and it can sit and abstract on the side. And then it doesn't matter whether your application teams are using Node.js for one service versus Java for other service, for Ruby or Python or whatever the heck. As long as it's on the network and some configuration, you can handle, you as a DevOps team or a SecOps team, then probably you can divide the work, and then each one can have their own separation of concerns. So that's the whole idea. And that's where service mesh, especially Istio, comes into picture. This is one of the diagram of Uber. I don't know if it's the real representation, but Uber being Uber, probably they have thousands of services and instances running there, right? So ultimately, you want to see when the network request came, where it went through. This is probably an example of an observability when you have hundreds and thousands of services running in your production environment. So what is a service mesh? Think of it like a network of microservices that make up an application, or I would call platform, and all the interactions among them. Not just from observability perspective, but also handling a lot of other operational things that we discussed on the previous slide. So the whole thing is, with containers and container orchestration, especially now Kubernetes, deployments of this microservice is quote unquote trivial today, I would say. I was able to bring up a Kubernetes service in what, 5 minutes. When Azure went down at the start of this presentation, I brought it up on EKS on AWS, and things are back to normal now, right, on AWS for me. So deployment of this, if you have good practices of Terraform or infrastructure as code, I should say, running Kubernetes is not a big deal today. I mean, all these popular cloud providers are providing that. With some more work from your DevOps team, you can write nice CI/CD and GitOps and Gitflow, and then also make your services deploy easily there as well. But getting those operational insight, that's the challenge that we are focusing today, because that is not trivial still today. You have to think about all those perspectives and multiple approaches, and then go from there and see what are the options. So at this point, in our experience, the options that we have looked into and kind of zeroed on is, of course, Istio, but you have a couple of other options as well, Linkerd, and then, of course, HashiCorp, being, I think, one of the oldest open source framework with, not with console, but yeah, with respect to console for the service discovery. They modified a little bit of it. They added one more feature so that this can become equivalent, I would say, to the other two, because these two are Kubernetes native. So Istio, as I said, it's actually based on Kubernetes. Google, IBM, and Microsoft use it for their internal Kubernetes managed services as well. I think it was, 6 months ago or something, they were, of course, they changed their open source organization from, they were supposed to go to CNCF, but now they are into what is that new organization? Google Open Source, something. So that's where Istio belongs. At this point, it's still completely open source. It supports Kubernetes, and it can also manage if you have virtual machines, just pure raw virtual machines and applications based on virtual machines running. It can also manage that kind of workload as well. It has the concept of control and a data plane, and there is a separation from who does what. We will discuss that. And then it uses something called envoy or envoy for the proxy management. That also will focus. Linkerd is actually, especially the V2 that came out, it's one of the second most popular service mesh on Kubernetes, according to some numbers there. Since it's Kubernetes only, it doesn't support anywhere else. So it's very simple compared to Istio, or definitely much simpler compared to Console, because Console came from the virtual machine cluster world, and then they retrofitted it to Kubernetes world. Linkerd also has separate control and data planes, and they wrote their own proxy in Rust. Hypothetically very fast. Probably it's very fast. I haven't used it. Console, again, from HashiCorp, pretty well-known service discovery, service management framework for a long time. Console Connect is the piece that enables service mesh understanding with respect to Kubernetes. It lacks some of the features compared to the other two. And also it runs in a different fashion. It runs as a daemon set. If you are aware of Kubernetes different way of running the workload, daemon set is a way of saying on each worker node you will run one process, one pod essentially, and it works with Envoy as well. So there is a link that we can quickly go through it. It's older though, so always check dates of any technical blog you are reading first. It's older, but it talks about the differences between all three of them feature-wise. I will probably share this link later, but you can see the description and where things are at this point, and maybe try it out on your own as well. Or maybe we'll have a separate meetup down the line to talk about probably comparison, at least between two, if not among all three of them. Cool. So going into it, there are more options, of course. Traffic is another one, which of course we have no understanding or experience with. I have at least heard about AWS App Mesh, which is an AWS solution for service mesh. It's a managed service from them, and hypothetically, at least I have again not tried it, but that can work with some other AWS services as well in a native fashion. And then of course there is some work going on in order to make it in the open standard using Open Service Mesh OSM standard. It's a CNCF project at this point. Sandbox, of course. We'll see how things go on this side of the world. But just like anything else, like open telemetry, open API spec, this is another on the same idea to create an open approach, or I would say API to bring all the concepts to a standardization. So that's the whole idea. Cool. Again, our focus is going to be on Istio. Now, again, Istio just needs Kubernetes under the hood. That means you can run it on EKS or AKS or GKE or anywhere where you can run Kubernetes for that matter. So whether it's Alibaba, IBM, OpenShift, Oracle Cloud Infrastructure, if you are still using that, or if you install a Kubernetes cluster using KOps, which is how at egen we started 3.5 years ago. Our initial clusters were done using KOps because EKS and AKS were pretty new at that point, and we were all on AWS at that point. And then, of course, if you want to use Kind and other sort of Kubernetes versions as well, or Kubernetes deployers, I should say. So let's go a little more into it. And the whole idea is, let's look at this scenario. You have an app, right? And that needs to talk to another app. That's it. Now, forget about Kubernetes, forget about Istio at this point, but let's say this is the only requirement you have. App A wants to communicate to app B, and both of them are within your cluster. And then if you support scaling or horizontal scaling in this scenario, you may want to invest into some tooling so that you can do service discovery, meaning how can you not worry about IPs and ports, but have a nicer DNS name. And then of course DNS resolution as well within the cluster. Maybe you want to keep it private, whatever, right? So those may be some of your starting requirements if you think about that. Now, if you are using Kubernetes for the same scenario, there is already a default option, a default or a basic level of service discovery and load balancing, which is available by Kubernetes service. It's a different object, just like you have deployment, daemon set, stateful set, ingress, you have a service kind of object as well. And if both of them, and this boundary is your Kubernetes boundary, then you just need to know the name of the other service. And then if there is not much security restrictions between two services, maybe if you are not using network policies or anything like that, some more complex concepts, you should be able to talk from one service to other service by just using the name of the other service. This is the most, I should say, basic level of service discovery and load balancing that will be available to you. If this service has 2, 3, 4 instances, this Kubernetes service will be able to handle that simple load balancing as well for you. So pretty much a very basic idea here, but anything more than that, probably you will start thinking about how to do it. Okay, so looks like we are getting questions. Will the recording be made available? Yes. How is service mesh different from the API gateway, and when do we use that? So I think I'm just thinking, should I answer it now or should I answer it later? I will just answer it later a little bit because I'm covering some of those concepts as well. And I think someone already answered. So yes, API gateway is going to sit on the boundary, especially from your outer world or public network once you want to enter into the cluster. So usually that's where you're going to put API gateway, unless you want to create your own private API gateway as well within the cluster using a private load balancer also. But then in case of service mesh, that can handle everything from even from one service to other service as well. Even though if the request is not going outside world and all the communication is within the cluster, you can still use all these concepts if you use service mesh. With API gateway, if it's public facing, your internal apps has to get out outside network, then reach the public endpoint or front end of the gateway, and then enter to the other service. So you may have a lot of round trips and latencies may be introduced because of that. And then also, why do we want to keep or move the network or the data out from the cluster if the intention was just to do service to service communication within the cluster? Okay, so this was the basic level of service discovery and load balancing available from the Kubernetes service. And most of the times this is going to be enough. We have almost half of the projects where that we just stop here and we don't think about Istio because or service mesh because it doesn't make sense, because maybe the cluster size is not that big, number of services are not that much. So we are like, why invest in that complexity? But we have some of the customers and some of the platforms where we have crossed this boundary and we have to start thinking about what's next. And that's where Istio, when you install it, start helping you. So when you install Istio within the Kubernetes cluster, it comes with, you actually install something called Istio, just like any daemon name that you will have in your Unix world, right? And then it has 3 components: Pilot, Citadel, and Galley. So the whole idea behind this entire set of components is actually to provide a centralized controller in the world of Kubernetes. Everything that you are customizing it's called controller. So what Istio would provide, actually, it's a centralized controller for validating, storing, transforming any configuration that your application teams or your DevOps team are giving to Istio, and then applying it across the cluster automatically. So that's the whole responsibility for all of these pieces. And if you think about, okay, what's the individual responsibility here? Galley is actually responsible for providing that configuration validation. Whenever you are submitting it to Istio, just like using kubectl, Galley will pick it up and then will validate and will process it and then will make it available for some other components. So that's the whole idea behind Galley, or the responsibility of Galley. Citadel, as the name suggests a little bit, this component takes care of entire identity and access management among the services. So what if, let's say, you want to bring authentication in the middle, where when app A wants to talk to app B, you want to bring some sort of service to service authentication from outside, right? So Citadel will have that configuration. What if you want to encrypt the communication when the data flows from app A to app B, Citadel will have that certificate management configuration as well. What is then this pilot guy? Well, this is actually the one that takes the configuration from Galley after it has been validated, and then it starts working with some other components in the cluster, and then start doing the transformation from whatever the standard format that was given to Istio by the user or the application team or the DevOps team, and then it will make it platform specific depending on where things are running and what you are using for proxying and things like that. Because remember, Istio can work with Envoy, Console, Nomad, anything like that, right? So although the configuration that you provide to Istio is same, internally Pilot will take care of transforming that to platform specific things. And of course, all of them are going to run as pods within the Kubernetes cluster. So all these three things are going to run as at least single replica within the Kubernetes cluster. So unlike Console Connect, which runs a daemon set on each one of the worker node, here these guys are only running one copy of each. And then comes the next important concept of Istio, which is auto-injecting these proxies. So there are a lot of words here, auto-inject and proxy. So let's first deal with proxy. And before we deal with proxy, one awesome pattern from Kubernetes, which is helping all of this thing to happen actually. So this is, if you think about the gray boundary here, this is, you can consider it as a Kubernetes pod. And within a Kubernetes pod, you have an ability to run multiple containers, multiple Docker containers, let's say, right? You can run it. So the new pattern has emerged with Kubernetes, and probably it was there as well before, but now more popular, and it's called sidecar pattern, meaning the service which is written by your application teams, you can run some sort of other ad hoc or maybe some corresponding jobs as a sidecar alongside those heavy apps. For example, app A and app B are written by your teams, and they can be whatever stack that they are using. The proxy is a small component, but it's going to be an important component for Istio. So that's a sidecar pattern, meaning you have a main container within the pod, and then you have a companion as well, or a sidecar, right? The beauty with a Kubernetes pod actually is these two guys or any number of containers can communicate to each other just using the local host interface. They don't have to require, hey, what's your IP or what's your port or anything like that. Well, they require port, but they don't worry about a host or anything like that, because they are sharing host or the network interface as well as the disk and the volume as well. So they can probably interact with each other just like multiple processes on your machine. So this is one benefit that you have, and that's what Istio is utilizing, and any other service mesh in this idea, in this world. What Istio uses is something called Envoy proxy. That's another proxy, I think from Lyft that they developed. So what Istio does, when you have your applications run like that in the Kubernetes world, and then you have Istio installed, and then you just label your namespace or your pods using some label, Istio can inject those sidecar proxies at the time when the pod is getting created or when your application is coming up, and it can configure all those proxies with whatever configuration was given to Galley initially. So that's the benefit, and Envoy takes care of rest of the things from that point onward. Envoy proxies are the only items or only components in this entire thingy which are really dealing with your data flow, right? The control plane, as they call it, this one does not deal with your data flows directly. It's just managing, monitoring, and then pushing out those configurations to the Envoy proxies. These are the guys, this is the component or the sidecar containers which are handling that really, the data flow really. And that's where Envoy's features now become Istio's features. That's the whole advantage here. Istio did not develop proxy or Envoy proxy, unlike Linkerd, here they just use whatever was the best available, which is of course Envoy in this case. So what happens now, instead of communicating with the apps directly or the containers, your app container within the pod, you don't know, but you start now communicating with the proxy, and proxy intercepts that request coming in figures out whether to do authentication, whether to do decryption if it was encrypted, and then passes over to the app on the local host. And then when app wants to send request to someone else, that transfers to proxy, and then proxy then encrypts it if you are using mutual TLS, and then handles for some other pieces before sending it out to the next pod. Internally there, it will be proxy that will be receiving that request. So this is a feature, a great feature from Istio, where your application teams don't have to worry about what the heck goes on, how to configure this. As an ops team, you can provide configuration to Istio and it will auto inject this proxies. There is a manual injection as well, but I would suggest auto injection to start with. And then these proxies will start caring about a lot of stuff, including if you want to handle HTTP, gRPC, TCP, WebSockets, anything. And then a lot of other features that we'll be talking next. The whole division initially I talked about, control plane versus data plane, is everything from Istio or Istiod, however you pronounce it, that is a control plane, meaning the separation allows you now to even run Istio outside the cluster maybe in third cluster, right? And that's where new deployment models of Istio also come into picture, because you can think of, if I just open here, you can think of deploying in the single cluster, what we have done, because your control plane can be sitting outside as well, right? Because that is not dealing with the real data flow. Proxies, once those are injected and configured, those are dealing with the data flow. By default, definitely this is the simplest example. Istio control plane actually sitting in the same cluster where you have the data plane, meaning your workload. You can actually keep the control plane outside, maybe in some other cluster, and then do load balancing or active cluster mode as well. So this is an example where this is in one cluster, this is another cluster, completely different region, and control plane is sitting in an outside cluster, Kubernetes cluster. You can do, what is this? Single network. You can do multiple network as well. You can do you can run control plane in one cluster, handle the traffic there, but then can also make it responsible to handle the traffic outside. Here, of course, it's running an external cluster. A lot of different options that you can try it out. And that is because of the separation of concerns between control plane and then the data plane. As long as Istio has access to inject those proxies, it's gonna be okay. You can run this guy somewhere else. And that's the benefit when you are on Google Kubernetes engine. It provides Istio as a managed add-on that can run outside of your cluster. And again, GK is much ahead in those two scenarios. So pretty important concept. Cool. And now let's just talk about some of these features, what Istio provides, right? Because this is gonna be an exhaustive list, and all other service meshes are gonna be, you're gonna be comparing whether these features are available there or not. So service to service communication, Istio can handle any traffic or any layer 7 protocol as well, whether it's HTTP or WebSockets. So it can handle that, including gRPC there. You can handle the mutual TLS, meaning encryption and decryption of the traffic between two services using mTLS, and all the certificate management will be done by Istio. You can also implement authentication and authorization among the services. So whenever you think of service to service authentication, you can do that using here. And then you can configure Istio to make it work with Azure AD or Okta or any OIDC compliant or auth2 compliant auth service as well. So it's pretty good. Traffic management, a lot of day-to-day, I would say, operational activities. What if, let's say, this service is not available and you don't want to wait for the timeout, you want to break the circuit, right? The pattern, circuit breaking pattern. You want to limit, you want to do the rate limiting. You may want to retry it maybe 3-4 times before the other service comes up, before putting it maybe on your DL queues or anything like that. Maybe you want to do blue, green, and canary deployments, right? So that's an example that we'll take a look into next few minutes. And definitely when you have a lot of these things coming, remember, all the data is flowing through proxies, and proxies can produce all those metrics out without application knowing anything about it. And all that can be aggregated and put into Prometheus, Grafana, or Jagger or anything like that for metrics, logs, tracing, traffic visualization. We'll see one example today. So a lot of good stuff going on. And then Istio can also work with or can push data to Datadog, or that's what we have been exploring, but not sure if Splunk or other pieces, but pretty good in that scenario. And then if you are at the height of cloud native testing, pinnacle, I would say, if you want to test how your entire distributed platform runs if a machine or a pod or a service goes down, right? How does it even react? So you can inject faults on while testing it, or you can do chaos monkey testing if you are very comfortable with the state of your platform. Cool. So it's a demo time, and before I go there, let's answer all the questions. Okay. So how is service mesh different from API gateway? I think I answered this, and Earl has also answered it already on there. And then Sudhakar has also answered it. So another question was from Sudhakar: does the Istio provide a default authentication authorization scheme, or we have to go for external implementation? So there will be one available using the YAML configuration that you may want to use it. You may start looking into it, but again, it's not gonna scale, right? So when you are thinking of Istio, see if you can integrate with some real OIDC or OAuth2 compliant auth service. There are options available with anything like Okta, authZero, same thing now, Azure AD or things like that. Does the communication between sidecar and app have much overhead and latency? Good point. That can be one of the problem when you are dealing with it. Not this much, I would say. If you are encrypting the data flow between service to service, that's definitely gonna be a problem. If you are having if you want very low latency, of course you may not want to do encryption unless it's very much required, right? So those are some of the concerns that you will see. This much may not be the case because you are still on localhost, right? Internally to that part. Cool. But again, depending on what you are doing here, you should be running some sort of monitoring based on your use case when you go out. Do it in lower environments or whatever environment. Try to figure out those numbers yourself, because with Istio's observability, you will be able to find out how your services are performing now versus after Istio. All those numbers are going to be in your hand. So you can do that comparison instead of waiting for your users to complain. Another question. No. Okay, something. Probably you are answering the question from the previous one.
So, Raveen, there's one question actually. This Istio, can you please go back to the previous slide? Yeah. So this Istio D has to be installed on all the nodes or only on master?
No, only on one Kubernetes cluster. That's it.
When we say cluster, are you referring cluster or one Kubernetes node within the cluster?
One time per cluster. That's it.
And that generally sits in master if we are not installing.
Doesn't matter. It will. We'll show you right now. When we install it, will go to one of the worker node.
Oh, okay.
Because it doesn't matter. Unlike console connect, which has to have one copy on each of the node because it uses daemon set.
Okay. And if Istio is outside of the cluster, let's say in some other, then it will talk to cluster using the APIs, the API of master.
Oh yeah, no. So what it does actually, it tries to talk to an Envoy API, which is here. So you have to make sure this API is exposed in a private manner and not going haywire to the public internet.
Okay. Yeah. Okay. Thank you.
Cool. So, as I said before, let's see if this is gone. Good that I had all the Terraform configuration to run and bring up a Kubernetes cluster on AWS within 5 minutes or so. Otherwise, yeah, this demo would have been disaster. So let's recover how many nodes we have. Okay. You can see my screen?
Yeah, we can see it.
Cool. Let's increase the font size. And I'm gonna be not liking this. Oh boy. You know what? I will just remove this thingy that I have. With this font size, it's not gonna work out. So let me just fix it. Syntax highlighting, not this, not this. Yep, this one. Cool. So at least you can see, because it was taking a lot of space on this side. What do we have? Okay, so not Terraform. We just need to know what's running right now. Cool. And just to confirm that this is, yep, the correct cluster. What do we have in the namespace? Nothing. It's a pure 80 minutes ago installed Kubernetes cluster on EKS. That's what we have for this. So the first thing is I want to talk about few different prerequisites, right? And what is the cluster? What apps are we going to be running for this particular test or demo, I should say. So you can install Istio in different ways. There is a Istio control or Istio CTL. I think the way you pronounce kubectl or kubectl or kubecontrol, you can use the same here. So they created a CLI binary that you can install on your client machine or maybe on your CI/CD agent. So that's Istio CTL, and that's the simplest one. You have to, of course, handle the binary, and you have to make sure the binary of this client is matching the binary of the control plane or the Istio, which is running in the cluster. So those kind of things. If you understand operator pattern from Kubernetes, you can run it as a privilege controller within the cluster, and that it becomes so easy. But again, remember, it's running with full privilege within the cluster. Probably you may not like it from security perspective, but definitely in that scenario, you don't have to struggle, or you don't have to worry about CLI or binaries or installing it on the client machines and all that. If you are into something called Helm, there is a way to install it using Helm as well, although it's alpha, but that's something you can try it out. One of the downside, if you use this, the features which are available from there in order to validate and checks on those installation configurations, those are not going to be available. But remember, here we are only talking about installing it. We are not talking about pushing our configurations for our apps to Istio. That's not the scenario here. That you can still do using kubectl or something else. Here, we are just talking about how to install it. If you have multiple clusters, I think I showed you the way. We are not going to be doing it today, but you can install Istio across different Kubernetes clusters in different deployment models where we saw it. We saw it somewhere. Yeah. Istio has pretty good documentation, I would say, compared to when they started. And then you can also make it work with virtual machines. So of course, the control plane has to run within some Kubernetes cluster, but then you can connect and monitor what's going on in virtual machines. So it will run an agent on those machines and do all this stuff. So for the demo today, what I have done and what we'll do actually, we'll install it using Istio CTL. This is the binary that I already have on my machine, and it's just installation pretty simple from there. So there are three important concepts that I will talk about, and then we'll also use these three things: Istio gateway, virtual service, and destination rule. We'll come back to this slide when we really look into the configuration. And this is the cluster that we intend to create on this Kubernetes cluster, and then these are different apps that we'll be deploying. I did not write any one of this code base. It is available from Istio's examples. So for example, what you have here is you have a Python based app, which is an API and a front-end app as well. It talks to a Ruby based app it's another microservice that's going to run, which is going to give you the details of the page or the product. Then you have 3 Java versions or Java microservices, which are going to be giving you reviews, couple of newer versions are going to be talking to some of the Node.js one to get the ratings out of it. And then one of the newer version of Node.js is going to talk to a database-based rating system. So a lot of iteration definitely has gone here, right? Maybe you started with V1 of this, V1 of that, and then nothing changed sometime. Then you release V2, which was using a Node.js V1 behind the scene. Then you release V3, which was now using V2. You can think of all these iterations or addition. So this is not, this is the current state of the platform, not how it was developed, right? When initially we went out with the product feature, probably you only had a monolith, right? And then you started creating microservices out of it with V1, V2, V3, all that kind of scenario. So this is the whole idea. How we enter into the traffic or into the, once Istio is installed and everything is configured, we will enter using AWS load balancer. The example when I wrote it, I was using Azure. So the only difference is a different DNS name. We will enter through something called Istio gateway. The logo is wrong now, but it was Azure load balancer. Now it will be AWS load balancer. We will enter through that using Istio gateway, which is, think of it like ingress controller. And then internally we should be able to see visualization of all this in real time, what's happening there. So that's the idea that we have that we want to implement. And let's just go ahead and then see what do we have on those apps. So let me minimize. So the first one, if I just show you, and if you are aware of even basics of Kubernetes objects, meaning deployment services, service accounts, and all that. So this particular YAML file, which is a Kubernetes configuration for all those services that you see here, okay, hold on. Can you see my screen?
Yeah, we can see it.
Okay, cool. Just want to make sure because I don't see the bar here which says this screen is getting shared. So what does it have? It has a service for details. Again, all the config that you see here has nothing to do with Istio. This is what you will do if you are using Kubernetes. That's it. Again, remember, whole idea behind Istio is your application developers or your applications don't have to change in order to support all those features. Those features will be coming with auto injection later, but this is what you will write even if you are just using Kubernetes and not Istio. So keep that in mind. There is nothing here in this file which is Istio specific. So you have deployment. You are saying, okay, the details service that you have is actually coming from here. Then you have another deployment for book info rating service coming from this Docker image. Again, examples, nothing else. And you have a bunch of them. The only thing important right now is, again, remember when we, let me just deploy it just like a simple Kubernetes workload, nothing to do with Istio, okay? So let me just do that. What is this? bookinfo.yaml. Because as I said before, basic service discovery, basic load balancing is anyways going to be provided by Kubernetes itself. So we just want to see what's that. So let me check the service. This is the load balancer getting created, or it's already created. Let's see. To expose that stupid app. What did I not type? HTTPS or TP. And then I think the service is exposing on some port 9080. Okay, and let's see if the pods are still coming up. Yep, they are running now. It will take some seconds to bring up the load balancer and make it active. Let's see what's going on there. Yeah, while copy pasting, I forgot .com. Okay, that's what happens when the default font size changes here. I just copied until here. Anyway, so we have this, and again, it's pretty stupid app. What do we have here is the details or the home page of the product page, right? And then this side is details and you have ratings coming out here. I'm just gonna keep it handy here so you can see what's happening here, right? And you will see something is going on. Sometimes you see red stars, sometimes you see no stars, and sometimes you see the black stars as well, right? So what's happening here? Again, no Istio, nothing. We haven't even installed Istio or talked about with respect to this demo. So what's happening here is at this point, the product page where I landed, this one, this is generated by this Python app, which is sitting here. And at this point, there is no gateway. We are directly entering using load balancer, which is this URL, right? The stupid URL. And then for this side of the page, the details is actually coming from this Ruby microservice. And at this point, we have these 3 services, but there is no v2 of rating and there is no MongoDB at this point. This one we will launch towards the end. So at this point we have 1, 2, all 3 of the reviews and 1 of the rating. And what happens here, since it's doing load balancing using Kubernetes service, again, nothing with respect to Istio, sometimes it will go to v1, which is not going to give you a star rating, only description. Sometimes it's going to go to v2, which is going to give you the black stars, and then sometimes it's going to go to v3 and it's going to give you the red stars. So depends totally whether it's doing round robin or whatever Kubernetes is thinking, which is not round robin. So that's what is happening, right? Without Istio, can you figure out what's happening, tracing anything in the middle? Well, unless you put a lot of efforts in finding out or implementing those tracing mechanism using Jagger or Tracer or anything, it's very hard to find out what's going on at this point. Again, there is no proxy, at least in this example at this point. You are typically dealing with directly Kubernetes service and Kubernetes deployments in Kubernetes paths. That's it. So that was a simple example that things work even without Istio, okay? And this is probably, in some cases, this is when you have to start deciding whether to go or not to go, right? Depending on the complexities of your environment, your cluster, your platform. So we saw it works. So I'm just gonna delete this guy for the time being, because next time we run, we'll run it with Istio, and it will be exact same fashion what you see here on the view. Let me get rid of all this workload and start thinking about deploying Istio control plane first. So it's deleting all of them. And by the time this deletes, let's see how to install Istio. So again, I will just go like how I would do even when I'm not presenting. So I went there, I saw installation, these are the options. I'm just gonna go with Istio CTL. That's a binary that you can install. Of how to get it, it's gonna be a simple binary available from istio.io. You can just curl it and then install it. Right now the version is 1.92. Remember, Istio has changed quite a lot from previous versions to this one. So always make sure whatever documentation you are reading is for the latest version if you are starting from fresh. So once it is there, that's it. That's the command. As long as you are kubectl'd, meaning you are authenticated to the Kubernetes underlying Kubernetes cluster, you just have to say Istio CTL install. And there are few profiles that Istio comes with automatically. Profile means what necessary components you want to install in the cluster by default. So you see Istio is there. That's always going to be installed unless you are doing something like this. Ingress gateway is going to be installed majority of the time. We are going to be using default profile. So think about it, right? What that means, you can control and limit everything that comes within the cluster, but you can also control what gets out of the cluster as well using egress gateway. But we don't have time today probably for that. So we'll just stay with the default profile, which is going to enable Istio, the core component, and also the ingress gateway, meaning a way to come in. So let me just go there. Hopefully everything is gone. The previous Kubernetes based, yep, everything is gone. So let's just do what version I'm running of Istio CTL. Let's check. Again, this is the same demo I'm doing for the first time because all my demos so far have been on Azure, which is down. So I think you will see the fun. If something doesn't work, we'll see. So let's install the Istio. By default, if you just do Istio install, it's gonna install the default profile, and you can customize it as well. So it's pretty simple way to customize this as well. You can just list how many profiles you have, all of them. And then I can just say install, but set the profile to default. Even if you don't say for default, it's gonna be default, but I'm just providing a way about how you can customize and say, you know what, choose this profile. You can create your own profile, you can output, or you can out this profile into YAML separately that you can utilize later down the line as well. So what did I do? Istio install double hyphen. Yep, it's gonna install this. Yes, I agree. Onto the cluster, underlying cluster that I have, and it's gonna run. The installation should be done pretty quickly. Again, this is one-time operation that you will do. What it's doing? Well, it's installing. Okay, this is where you have to get out of the presentation mode. And this is wrong presentation. Where is my presentation? Here, this one. So what it's installing right now is the control plane that we have seen before or discussed before. Cool, and that's done. That's how easy it is. So the next thing we can do now is let's check the status whether things have been installed or no. So it actually gets installed in its own dedicated namespace called Istio system, and we can see what's going on there. So get all the paths, see the health of ingress gateway and the Istio component, at least both of them. So let's see, paths or deploy. What is namespace? Istio system. And of course, both of them are running. So ingress gateway is running and Istio is also running. If you want to check where are the paths, you will have that entire, all the components, Galley, Citadel, and what was the pilot, they are all running. And then of course, the additional component ingress gateway is also running there. So things are running well. Now let's talk about, because previously when we installed or we deployed our Kubernetes workload, this guy has no understanding of Istio, right? So how would Istio do something called auto injection of those proxies, right? Because it has to figure out, because otherwise Istio is not going to be like, well, I'm just going to start bombarding all the deployments in your cluster with all the proxies. No, you have to selectively opt in. And the way you do it, two options. So either you actually go for manual sidecar injection, where you can use Istio CTL command onto your deployment YAML, and then what happened? Here, and then you can edit it. So that's a manual sidecar injection. What we will do is actually automatic sidecar injection, but that is also opt-in, meaning you have to tell your namespace and you have to put some label on top of it, so that Istio is like, you know what, yep, I'm only gonna deal with this namespace and everything running in this namespace. I'm not gonna worry about something else. So the workload that is getting run right now is actually in, we'll just go with default. So I'm just gonna taint, or I should say I will label this particular namespace. I'm just gonna say give this default namespace a label called Istio injection enabled. That's it. It's a pretty simple process. Labels don't do anything unless someone wants to do it or use or make use out of it. And let's confirm that the namespaces have Istio injection label created. So yep, Istio system, of course, you don't want to run Istio capabilities on top of Istio components. So for default, we have it enabled. For this one, it's disabled. For others, it's unknown. So Istio will not care about it. Only thing it will care about is, or it will do auto injection for the workload running in this namespace. So once that is done, one thing that I did for testing, actually for book info before, was actually I added a load balancer so that we can reach out from here, right? On this load balancer right now it's gone, but you get the point. We don't need that with Istio or anything actually, if you're using ingress controller and all that. So I'm just gonna comment this place out. In a real environment, you will not have that anyways. This was just for the demo for deploying and make it available and have you see at least how the app is looking. It's so bad. So I edited that, and now remember, Istio injection is auto injection is enabled for anything that gets deployed in default. So far, when we deployed it before, we just deployed bare bone Kubernetes services. There was no proxy, nothing. So let's deploy the same workload this time. But again, remember, Istio is already running in the cluster, right? So where is it? src book info. Same set of things are gonna require. There will be one critical difference though. Last time when it was running, they were all running one container per pod, right? Because they were pure Kubernetes objects. So this is an important thing to see here. If there is another container coming here, the sidecar pattern, right, with the proxy, we should see 2 out of 2 in this case once these things are ready. And if that is not happening, that means you don't have proxy injected by Istio. But in our case, we have it, right? So why it's saying like that? Well, because it has injected the proxy. So within the pod, you have 2 containers running now, your app and a proxy. If you want to describe it, you can actually see both of them running. So let's go into the product page and describe and see what else is going on here. So if you scroll up, there's a lot of detail here. So Istio, as part of the auto injection, did a lot of stuff. It added some more labels as well. That's how it will use to figure out what to do with your what sort of config to push out to your app, your pod. And then of course some sort of annotations as well. It has added, it has created an init container as well. When the pod is getting initialized, it's initializing some configuration within it. And this is your main container, the product page, which is your application. But then it has injected the proxy. So you have additional container here. This is your sidecar, or this is your proxy. And if you see, it's coming from whatever, docker.io, Istio image. So again, you didn't worry about all this configuration or what the heck is going on here. So many different environment variables you have to provide if you were configuring it manually. But Istio is doing all this thing for you. There are some volumes attached as well with respect to some secrets and all that, and things are running. So that is first benefit we already saw, meaning without a change from the application's perspective, we are able to get these things up and running. Cool. Any questions so far? And your first question will be, fine, but how do I enter into the cluster? I don't have a load balancer based service anymore. I have services for sure for my apps, but these are all cluster scoped. There is no private IP, public IP here. These are all private IPs of my VPC. So what's going on? How do I even enter into the cluster and see the magic, right? What is missing? This guy, Istio gateway. So this is the first time we are talking about what is Istio gateway. Now, again, if you are coming from understanding of Kubernetes world, the pure basic Kubernetes world, there is a concept of Kubernetes ingress with ingress controller. That's, you can think of similar to Istio gateway, but a lot more features on top of it. So when you install in Istio gateway, it actually works with your load balancer and it operates at the edge of the mesh, something exactly like this diagram. It will work with load balancer. You can configure your DNS automatically using some sort of configuration, or I will go and hard code it for this demo. And from a URL, nice URL, it will come to the load balancer, and from there it will forward it to the Istio gateway. So when you install it, it can handle HTTP and TCP communications. If you look into the real Kubernetes ingress object, which was Kubernetes way of handling or exposing your services to the outside world, you do port setting there, you do protocol setting there, you do service setting there, but then you also do routing setting there as well in the same object. In Istio, those are divided into gateway and virtual service. So of course, Istio gateway provides more customization. We will see one example there. And you remember one of the default controller was created, right? The in the Istio, what is it? System namespace. So that guy is already running, and actually that has tied itself to a service already. meaning you can use this load balancer, this guy, to reach into Istio, but then Istio doesn't know what to do with your request when you reach it here, right? So that's what we will do with our first gateway that we'll install. But by the time I do it, I don't like this long URL. I'm just gonna change if we have something with Route 53. In the real world, you will not do it manually like this. You should have some automation, but let's see if this works out. Oh yeah, I have it. I'm just gonna create a CNAME record. I can just do A with alias and point it to, oh boy, it's a network load balancer in US East 1. Or it is not network load balancer. Then what load balancer is this? Classic load balancer, yes. So here, which one? Not this. This one, because I have the URL with me, right? AE7A. Yep, this is the one. So app.aws.collective.ac should go to this long URL. Oh, really? Last demo. Yeah, kill it. Or I can just edit that itself. There was a same record for one of the last demo that we had somewhere. So cool, at least it's not timing. It will time out, but definitely not saying not found or anything. So it should be available in few seconds. How much time? There is no TTL, so it's internally regulated by AWS. Coming back. So we'll have an awesome URL. Let's not worry about that piece. Now, the first thing we have to do is to to install this, our service specific gateway. And I have the configuration for that already. And I have both of them. I have a gateway. And if you can see, it's pretty simple. It's saying, oh, I'm naming it book info gateway. Use the controller, which is already running here, meaning use the same load balancer, just like Ingress controller. And then accept the traffic on port 80 and then accept it for any host because we are not going to be specific here. And then I'm using a virtual service. So what is virtual service doing on top of the gateway? So use virtual service to handle the traffic routing, meaning if this is the path, go here. If this is the path, go into some other set of services down the line. So that's virtual service. There's another concept called destination rule. And there you define policies that, you know what, I want to use round robin way of load balancer and not FIFO or something like that, right? Or last in or whatever other configuration that you have here. Or I want to handle connection pool size of how many backends I can have. Or I want to figure out, you know what, V1 means these 3 paths and V2 means this guy. Or if there is a unhealthy pod behind the scene, then I want to remove that from my service discovery configuration. So that entire configuration is done using an object called destination rule. We already saw virtual service and Istio gateway. So if I go back here, what did I do? Okay, so this is one object, which is gateway, and this is another object, which is saying, well, for the time being, you know what, move everything that comes on any one of these paths to product page, which is the front service, the first service, because we don't know what else to do at this point, right? So we'll just move all the traffic to this guy for the time being, and down the line, we'll start handling other pieces and start moving traffic here and there and other things. So let me just apply this. I just want to make sure. Yep. So at least it's not failing into DNS issues. Okay, so what do we do? Oh, we apply bookinfo.gateway now. So apply and this guy is gonna create 2 different things, right? It's gonna create a configuration for gateway and then also create a virtual service for routing this traffic. For all these paths, send the traffic to this guy on the port 9080 of the one thing I missed here is I did not implement SSL behavior at this point, so I will just go with the normal URL because long story, probably collective.ac require you. Let me just check. No, I'm good. I was wrong. I thought this domain requires HTTPS by default, like .app, but I'm wrong. Cool. So we have the app here, and then you can see same thing is still happening, but this time using Istio, because everything is running in Envoy proxy and things like that. So what happens? It's doing round robin or whatever the default is. It's bringing up black and red, and sometimes you lose the rating because of different versions of the review service that is running there, and it's just doing some sort of load balancing across those three of them. There is nothing, there is no V2 right now, there is no MongoDB, so keep that in mind. We'll install it as part of our demo. So that was the first thing. Now you will be like, which is, I still don't see any difference. What the big deal here, right? Can we capture any one of these metrics? Can we see, or can we see it visually on some platform, some tool that, okay, what's happening with your network flow here? And that's where Istio comes with a lot of things pre-packaged. Where is it? Integration. So it can integrate with Grafana, Prometheus, Kiali, which is actually a pretty solid tool to monitor your service mesh, and that's what we'll deploy. I will deploy a lot of other pieces as well, like Grafana and Prometheus and Jaeger and all that, so that we can see a lot of data around what's happening within our mesh, the observability part of it, right? So I have all of them in this add-on. Again, these are all available from examples. I did not create them. I'm just gonna apply them. Where are those? SRC add-ons. There are a lot of them. You have configuration for Kiali, Prometheus, Jaeger, Grafana, and then Zipkin and other things as well. So let's do that. Where is it? Here, and it will run all of them. What we'll do is, as soon as it's up, we will go and these are custom or CRDs, custom resource definitions, so it's gonna take some time. I will apply one more time. Cool. So looks like everything is at least running. See if Kiali is working or not. Yep, Kiali is running there as well. What about all the pods? Yeah, that is running. So let's open up the Kiali dashboard to visualize exact same diagram that we see here, but with real traffic flowing. That's gonna be interesting. So you can do it using just by running the command to bring in Kiali. Where is it? Here. It's already installed. Visualizing your mesh, and I will just say istioctl dashboard Kiali, and it will open an SSH tunnel from my machine to the pod which is running in here. Cool. And it's coming up, and it has detected entire workload that we deployed, and this is one of the coolest thing ever. Let me just click on a few things. So let's see request percentage, we'll see service nodes, we'll see security, we will see traffic animation. Let's just animation, nothing else. I think enough. And I will want to use default. So what's happening right now, since there is no traffic flowing, right? I did not click on some things here, refresh here. So let's see if you start seeing the traffic. Yep, you can see what's going on here. 50% of the traffic, when it's hitting, it's going to the details. If 100% is coming from here, 50% here, one third on all of those three versions. And then both of the V2, V3 of reviews are actually using Node.js based app of ratings. So which is just very stupid app. This guy, right? So you can easily see what's going on here. Seems like there was an initial outage that it had detected, but nothing crazy apart from that. So what's going on? 100% of the traffic that comes is divided, which is a strange way of saying stuff here. Some of the requests, because remember the same page is making two calls, right? One for this, one for this. So two calls, 50%, meaning each call, one call is going here, one call is going here, and then the corresponding numbers that you will see. Things will not be always 1/3 because one request may be more than the other, right? Or the total count may be more. So that's pretty much what are this. Different visualization. I think we'll just stay with this one. It's gonna refresh every 10 seconds or so. So I will have to find out some way to refresh this guy automatically so that we can keep traffic seeing. Otherwise I don't want to hit refresh. I have some shortcut here, again not related to Istio, just some script to run this stupid keep on refreshing this page again and again. I don't want it, so let's see what happens. I'm just refreshing it again and again. How much time does it gonna take? 10 seconds. Oh yeah, it did refresh. Let's reduce it to maybe 2 seconds. You want more data to see. Yeah, it will keep refreshing automatically every 2 seconds. Let's not worry about this. We'll see the visualization of what's happening in terms of traffic. We can also see how much response time is coming through across those edges. So 41 milliseconds from here to here, 24 milliseconds, 10 milliseconds. Again, this is all internal cluster traffic, so no big deal. What else? We can have requests per second as well. How many requests per seconds are going at this point? So a lot of these metrics or visibility now you have into your cluster. Before, you probably didn't know what's going on. So we'll go back to the request percentage because that's what we will try now. So far what we did, we just said, okay, this is the way to enter into the platform or the cluster. From here, get details from there. For reviews, do round robin between 3, and 2 of the versions are pulling rating from that Node.js by Zap, where it's gonna give you colorful stars, right? If in some case it's not giving you colorful stars, that means it went to the V1 for that instance. So that is what going on right now. Cool. Let's quickly complete the other part of the demo as well, and that's where a lot of capabilities of Istio are now into the picture. So let's first look into, because what we want to do next is create some sort of division between saying, you know what, this means V1 and this means V2. This means this set of pods are called in a set and will be grouped in a set called V2, and then we'll do more 50-20 or 50-30 or 50-50 kind of division of the traffic. So let's see what do we have here. So here is where we are creating our first destination rule, and in this case we are just identifying subsets, which is a property, which is a type of configuration in Istio. We are saying whoever has the label version equal to V1, call that, just rename it to V1 subset. Same thing with there are 3 in reviews. Rating has 2. The other ones we are not even using at this point, so that's okay. And then V1, V2 for details, we'll not use details V2 either. So this is just saying, okay, I'm setting up the groups going forward, because virtual service will use those groups going forward to do your traffic shifting. So you know what, let this guy run. I'm just gonna open a new terminal. I don't want Kiali to stop, so let it run. And then let's apply all these default rules, destination rules at this point. Where is it? SRC destination rule. Okay. So I applied all of them, and this will not change anything because there was no information here about what traffic shifting we want to do. 10%, 20% to this, 30% to this, nothing. So this is just a way for our first demo. And what we are gonna say here, what's happening here, the traffic here, for example, is going to V1, V2, V3, right? We want to say all the traffic goes only to the V1s of all these services, right? So we want to kill this traffic. And once you have destination rules applied, then let's say, okay, this particular thingy configuration says When you are asking for product page, send it only to the V1. When you are asking for review, send it only to the V1 version of it. When you are asking for ratings, send it only to the V1 set, right? So the whole idea here is let's start with setting everything with V1 traffic, right? No V2, nothing else. So that's the case. Virtual service, all V1. We are just configuring more services. And since these pages keep on refreshing, we will quickly see the traffic getting reduced on all V2 and other pieces, or V2 and V3 here, and everything will start going only to V1. It's refreshing every 10 seconds. That guy is refreshing every 2 seconds. So let's see what happens. You can see what's happening here. This was only V1, so no issues. Here, it's just 2/3 of the traffic going there because it's last 1 minute. And eventually, yep, this is dead. There is no traffic flowing there. This is 9%. In the next counter, it will be dead as well. And all the traffic will go to only V1 of this service. Hopefully that happens in the next counter. Yep. So now 100% of the traffic is going to the V1 review, and you can see this is dead. That means there are not going to be any stars because those were coming from the V2, V3 service talking to this Node.js service, right? So you can think of what's happening here. Cool, we saw that. Now let's do a 50-50 between two versions, right? So the another virtual service configuration I have is, you know what? When someone is requesting or asking for reviews service, send 50% traffic to V1, send 50% traffic to V3. That means V2, we are not sending anything, right? So again, configurable option here, and then we can just try to apply that. What is it called? Reviews 50 V3. Okay. Again, we are just changing those services that we had. And now again we are keep on refreshing, but the whole idea is only send 50% to V1 and V3, nothing to V2, right? That was the logic. I think that was the logic. Yeah, V1 and V3. So V2 will still be dead, but you can see the traffic now coming up on V3. So this will be split into half and half closely in the next few seconds, but you get the idea. So again, what you have to do next is probably go through the configuration understanding of these virtual services and just keep playing with that. I will just give maybe 3-4 more examples and then we'll break up for Q&A. What if, let's say, we want to route 100% of the traffic to V3 of review? I have some configuration for that as well. Let's apply that. In this, I'm saying, you know what, point everything to V3. Don't even worry about doing V1, V3, V2, anything. So let's apply that. What is the name? Reviews V3. Yep. I'm changing the same exact service again, virtual service. So in few seconds you will see, because it's running 1 minute and 10 seconds late and the traffic is coming every 2 seconds from here, it will start moving all the traffic to V3, and that's pretty much it. So this is pretty simple traffic shifting. Did I click somewhere? Okay. Traffic shifting, that's you are able to see by changing the sets using destination rules and then playing with this configuration in virtual service. You can take control of a lot of those things. Pretty simple. Once you understand, you can see V1 traffic is shutting down now and everything is moving to V3 because that's what we said. Cool. Now let's do a couple of more examples. One, let's try to introduce a fault, a custom fault that, you know what, maybe one of the service we want to make it unavailable. Where do I have that? Testing the delay. So what we'll do, we'll say if someone is asking for ratings on HTTP, introduce a fake delay of 7 seconds for all the traffic, okay, and route it to V1 of the rating service. So that's what we want to do, introducing the fake delay. I'm just gonna roll back some of the changes that I already did with them and go back to this level. Okay, and then now apply this fake delay thingy and see how our system performs, or how does it even handle that fault injection. Ratings, what is it? Test delay. Okay. So ratings is now configured again, and let's see if you will see some red boxes somewhere. Hopefully. You know what? Our delay is 7 seconds, and I'm refreshing every 2 seconds, so it will never cross it. Let me just change my refresh script for a bit. Make it maybe 10 seconds. Okay. Yeah, you see what happened here, right? We said, what did we say? We said 100% of the traffic for ratings, if it's going to V1, introduce this fake delay of 7 seconds, and that will break some of the things ahead, and you can start seeing what's happening here. Whenever it comes here, V3, whenever you are trying to make it talk to rating service, 100% of the traffic is going to the dead zone, right? Or dev null, whatever, because this is not available. So this is introducing a fake delay, and then you can see, you know what, we brought it down. How does our app handle now? So of course there is no rating, so there are no colorful boxes, but then whenever it tries to talk to it, it's saying rating service is currently unavailable. So this is a way where you can do some testing or inject fault automatically. One last thingy before we do anything else. Let me go back. Let me remove this service, because so far what we have seen actually are on the HTTP layer, right? What if we are running a database and we want to communicate on TCP? Can Istio control anything on TCP? So this is where I'm going to introduce MongoDB running in a pod. Let's not argue about whether you should run it or not. That's for later, some other calls. I will launch a V2 version of this service and move the traffic from V3 to V2, and V2 will be using MongoDB for storing those ratings, and we'll see something else. And we should see traffic flowing on there as well. So I deleted the rating service. I don't need it. I have a database pod, which is MongoDB here. So I'm just gonna deploy that into the cluster. Ideally, it will be sitting outside of your cluster, but you get the point. Did I do delete? Awesome. So let's do apply. So I install this service, the MongoDB service now. Will it show up in Kiali? Am I saying show the unused nodes? Now it should show. Yeah, this guy's sitting. So it detected that, okay, I found something new into the cluster, but no one is sending a request to it. So that makes sense because we did not connect it yet. We only started this guy. We had to run a V2 installation first. And I have configuration for that as well. So this is rating V2 service. What it does, it actually depends on that MongoDB service in order to do something. So let's just bring up this V2 service as well. V2, yes, V2. And then once it's created, a new box should come up here in the next few seconds. Again, it's the end-to-end connectivity has not been completed yet. So let's see how, yeah, you see V2 is here, but it's just sitting there. There is no request routing going on. Everything is still going to V1, which is doing whatever round robin here, nothing major. So that is still going on there, right? Let's connect this MongoDB to V2. So V2, when it comes up, where is it? Here. So we'll create a new virtual service. We'll bring up review V3 and then also ratings to V2, and then they will be communicating as well. So let me apply that. Where is it? Virtual. And as soon as we do, Istio will detect the changes, and yep, you saw it right away. And it detected the chain of where things are going, and it has rearranged Kiali's dashboard. And now the traffic is flowing through V2 and MongoDB going to that MongoDB database. So now this guy will keep on running. All the traffic is going through there. If you want some better some more visualization, some more ideas of what's happening, you can check it. You can also see whether the traffic is encrypted. So by default in this example, all the traffic is mTLS, meaning encrypted between the services. So that's where you see star, including TCP. And what else? Request percentage, request per second, anything like that if you want to know. Let's see the stupid animation. Does it not work? Oh yeah, it does. Again, this is not real data flowing, but you get the idea of where the data is going through. So I think that's what I have in the examples list, but you get the point. Using these configurations on virtual service and on your gateway and your destination rules, you can achieve a lot of these features, again, without changing anything in the code. And if you want to go more, you can also think about in terms of the authentication and all those pieces. Cool. So let's finish up today's meetup with some takeaways. So Kubernetes is a complex platform. In order to run it, I mean, that's complex. In order to understand for your DevOps team, that's another set of complexity, right? So definitely think of using some of the managed services instead of rolling your own, unless you are very comfortable. And then Istio, if you use it, it has definitely added one more level of complexity on top of it, right? So think of like platform running on platform, Inception level 2. So you have to understand what's going on within Istio. You have to probably go through a lot of learning there as well. Before you think of Istio, make sure your CI/CD and infrastructure automation is in place. Otherwise, you will be so much running into confusion of where the data is flowing and who is responding to what and all that. You don't want to deal with, at least with the infrastructure automation and CI/CD. So do that first, then Kubernetes, then Istio. That's the path if you want to get complexity. And also make sure you have some observability tools. So whether for centralized logging, tracing, Datadog, Splunk, Elastic, APM, whatever. And then if you don't, then you can start small with all the tools coming from Istio, but you can integrate a lot of them with if you are already using some other tooling as well in terms of monitoring and all. One question I think someone asked, so Istio may add some performance latencies, especially if you're using encryption, for example here. So make sure you actually enable and disable it and then find out numbers, because remember, you can actually look into the numbers and find out what's going on here between all these things, right? If I should remove animation, it's stupid. Yeah, so it will start showing you good numbers and a lot of other things as well with respect to metrics for your network flow. Use that to determine what is Istio adding. Is it adding any latency? Is it adding any more complexities or anything like that? So you can compare numbers to numbers. Another thing you have to keep in mind is when you have added this proxies, right? They also require some CPU and memory. May not be as much as what your app requires, but if you have if you use Istio for hundreds of services, even small stuff will add up, right? So account for that in your resource quota when you are thinking of, you know what's gonna be the quota for my pod, my service. So account for that when you think like that. And then definitely here, you can separate the concerns of DevOps from security ops and from application teams. That's one of the nicest thing about using configuration management here with respect to Istio. So that's pretty much what I have. I think it looks like there are a few more questions. So let's go and then go through it. So first question is, does this keep TCP connection alive throughout the chain of apps? Istio won't do. Oh, you mean what's happening here? We'll have to find out. I know what you are talking about. You are saying, well, what if, let's say that was a database, and if it's using connection pooling, then is it gonna keep that connection alive? We'll have to probably find out and see, specifically with the TCP layer. It should not though, because then you are going into too much of the details, right? Istio shouldn't go into that much detail of connection pooling and whether it should keep it alive or no, but we can see what's going on. Pros and cons of load balancing at an API gateway versus Istio gateway, or is Istio gateway acting as an API gateway? Yes, the second statement is true. But then you will be like, you know what, we are on cloud, we already have these managed services for API gateway. At least let's use it when the traffic is entering from the public to us, public internet to us, and then handle a lot of web application firewalls and a lot of that stuff outside the cluster. You can still think like that, right? You can use the API gateway at the front, and once you enter inside the cluster, then you hand it off to Istio. That's a way to probably you want to think like that. Cool. Can we ignore few pods in namespace? Can we drill down to the pod level? So what Istio is using actually is just using the labeling of it, right? So if you don't want to do that, you can opt in for manual, injection. Where is that? Probably somewhere. So you can do that, or you can do some sort of exclusion as well there. I haven't tried it, but shouldn't be a big deal using combination of both of them. Can we define conditional traffic routes with Istio based on the response type, etc.? Good question. With the response type, no, but with the request parameters, yes. Anything that is on the request. What would you recommend for automating deployment like this? A lot of stuff. So you will have to, here two things are going on. Deployment of Istio is easy. I mean, you can merge, or you can bring Terraform, which you may already be using it. This is one more component on top of Kubernetes, just like 5 other things that you're going to be deploy when you run Kubernetes for the first time. That is okay. The complexity is, where should this code live? And that's when you should start thinking, how are your teams actually providing this configuration to you? Are you using GitOps? Are you using YAML like this? Or are you using Helm? Or are you using Terraform provider for configuring this YAML files, right? Because some way your teams are using it already if you are on Kubernetes. Other things, what's the difference between, let's say, this guy? The only difference is this is a custom resource definition, a CRD. Terraform does not have right now support for CRDs unless you use alpha version or beta version of their Kubernetes provider. So you probably have to start thinking, okay, if you are already using something else, what goes on now? Should you use Helm? Should you roll out your own provider? Should you just learn to deal with YAML? So those are some of the things. Because yeah, the concern here, for example, not concern, this will be the responsibility of the app teams or whoever handles it within the app teams, right? Because these are specific to the apps. You cannot generalize these rules across your clusters. So this should be in the hands of application teams, or you write some wrapper on top of it and just tell them to write some variables. While the Istio installation and then these add-ons should be in the hands of DevOps. I think that's what I meant when I said something about DevOps versus SecOps versus application teams, because now SecOps can take care of the authentication service. So they can make sure integration to authentication service, auth service, everything is going on.